Hey guys, wanted to give you a really quick, really casual run through of the additional problems tonight on the homework. It's a little bit of a doozy, but you need to know how to do all these things for the quiz tomorrow. So this first thing that we have going on, we have an electric field that's accelerating the electrons. That's this region down here. So over to the left of the plates, before they get through the plates at all, they've got to be sped up to make the electric field has to speed up the electrons from rest and make them go fast. So that right there, I mean, that's energy. We have something going from not moving to moving. Something has to give that energy. The electric field is going to do work to make that happen. We had a homework problem last night, number 61, I think, that dealt pretty much exactly with this. Find the change in kinetic energy. Now, for this, you'll need the mass of an electron, which you can go look up. And then you can use that as the work, and then from there find the force, and then from there find the field. You should be comfortable doing all of that. So that's part A. You'll have the electric field over here, but of course you now no longer need it, because now we're in this area where we have an electric field that we know it's this value, and it's going to deflect the electrons upward. We want the electrons to go through, be deflected upward, and then go up to hit the screen. So for this situation, you need to think which plate is going to be positive, the top plate or the bottom plate. How is this field going to point to pull the electron upward? You should have no problem with that. Okay, now the electron's going to fly through the plates, and then how far it's going to move up while it's in the plates. Now, this is a projectile motion problem. It might not look like it, but this is projectile motion. We have some horizontal motion, and then we have some vertical motion. Now, in this next little bit, show why it is a reasonable assumption to neglect gravity, meaning we're going to neglect gravity for this whole thing. Electrons are very tiny, so, we can basically ignore the force of gravity there. So in this scenario, the only acceleration we have is the electric field, the electric force pushing it up. Nothing is pushing it forward or backward anymore. The electric field that was over here, no longer on, or no, it's not affecting this region. And all that we have is this vertical electric field. So we have one force pointing in the y direction, no forces in the x direction. This is exactly like projectile motion, except instead of gravity, we have the electric force. Instead of down, it's pointing up. That's the only difference. So the time required for an electron to move to the side from here to here, this 0.04 meters, well, in this case, we know a displacement, we know our delta x, we know our velocity in that direction, not the velocity up or down, but our velocity in that direction. Find time. That should be trivial for you. Vertical displacement. How far is it going to move up? Because it's going to bend a little bit. How far is it going to move up? What's going to be that thing? Now, there were plenty of times throughout this year where you found the vertical displacement of something like falling off of a cliff or falling down or what have you. Something rolling off the side of a table starts going like this. It falls for this many seconds. How long does it fall? Or how far does it fall? Same idea here. It's kinematics. Kinematics will never, ever leave you. So in this scenario, it's coming in totally horizontal. Comes in horizontally, which means there is no vertical velocity yet. Well, okay, how are we going to find the vertical acceleration? Well, look up here. Where was this? We have the electric field. We have the charge of an electron. We can look that up. We have the mass of an electron. We can look that up. And we can use all that to find the acceleration inside there. Newton's second law. Come on, you got this. And then, what is happening? Mr. Ayers is playing around inside here. Oh yeah, you're going to need the 0.02 meters. That is a very important part of this to be able to calculate this stuff. My bad. So anyway, you got this electron, it's going, and it's being deflected up or down or whatever, or up. In this scenario, we've now figured out the initial vertical velocity. Doesn't have one. We know the time because we just calculated it, and we know the vertical acceleration because we calculated it using Newton's second law. So from there, it's just basic kinematics. Figure out how far up it goes. Easy peasy. Show why it is a reasonable assumption to neglect gravity. Now, you could give me this answer in words any time of day. Give it to me in math. Figure out a number, get a math answer, and then interpret that math to get the point. That's how AP would grade this problem. And then, still neglecting gravity, we describe the path. Now, descriptions of paths can be based on two things. They can be on the actual drawing or with words. Do both. Be comfortable doing both. Up here on if you print this out, you can draw a picture. You can say what exactly the electron is going to do while it's inside the plates where there is an electric field, and once it's outside the plates where there is no electric field. Realize that we're ignoring gravity. So think about what forces are existing when it's outside of the plates, and think about what that situation should result. If there are forces, think about what those forces will do. If there are no forces, think about what the path will look like. That's all. This will help you on the quiz tomorrow. Do this problem, do this problem, do this problem. See you then.